All right, welcome again, everybody. Just a reminder, we cannot see or hear you, so any questions that you have, please put them in the chat. So we are now going to get started with the Hurricanes on Long Island program. You could take it away, Jeffrey.
Oh, hi, and good evening, everyone. This is Jeff Tong. I'm a professor of space and natural sciences at the community college. And our presentations are offered through our faculty association free of charge to virtually anybody who wants them. So we've done these for libraries and social groups, civil groups, such around our county. So what you see there in front of you is a picture from the International Space Station of a major hurricane. And what I want to talk to you tonight about is something that's near and dear to me, is the science of meteorology and these storms and how they will impact us again on Long Island. So to talk a little bit about the science of this and some information, but most importantly, I want to make sure you get the right information. So much has happened in the past 6 months. We hear all different things, so sometimes we don't know what to believe. And that's sort of the way it's been with meteorology sometimes. You'll be standing in the grocery store line and the person in front of you says, "Oh, I heard there's going to be 6 to 10 inches of snow." And the other person responds they're talking to says, "Oh, no, I only heard 3 to 4 inches." So I want to show you where the information comes from and how you can interpret that. And then most importantly, talk about our local impacts on Long Island and give you some takeaways. And finally, we'll take a look at what's happening currently on the planet in terms of hurricanes. So I grew up on Long Island in Nassau County. I graduated from high school, went to the community college, went on to SUNY in Oneonta. I got a degree in meteorology and went on for my master's, finishing that in 1983 in meteorology at Texas A&M University. In 1983, I was also commissioned a second lieutenant in the United States Air Force. And lo and behold, I was lucky enough to be sent to Edwards Air Force Base out in California, where I was providing weather support for the space shuttle as a young 24-year-old second lieutenant. So that was pretty exciting. I went on to Scott Air Force Base, became a captain in the Air Force, and left active duty and joined the Air Force Reserve and continued full-time employment in the private sector, or actually public sector, where I went to Florida. I worked for the Water Management District in South Florida, protecting the Everglades as a meteorologist. In 1992, I went to Johnson Space Center and continued to work for Shuttle and became a lead forecaster for shuttle operations back in the early 90s. I came back to Long Island and worked at Brookhaven National Laboratory for 25 years as the Science and Operations Officer for the local National Weather Service. Since 1998, I've been teaching meteorology at Suffolk Community, and I've also taught meteorology on the graduate level at Stony Brook. So let's talk about hurricanes. Here we have what happened 2 years ago, 2018. You may or may not remember any of these storms because none of them truly impacted Long Island. As you can see here, there's a lot of spaghetti on the plate tonight, and we have storms that tracked into the United States. The first of those was Florence here. I'm pointing out the purple here means that it was a major hurricane. It actually became a Cat 4 hurricane as it approached the Carolinas, and fortunately it weakened as it crossed the Gulf Stream. So we're going to talk about why did those things happen, because I'm sure you know that the hurricanes get their energy from the warm water. So why would it weaken crossing the very warm Gulf Stream? A few days later, though, we had Hurricane Michael, which struck the Panama City, Florida area as a Category 5 hurricane. It's one of the only been 3 Category 5 hurricanes to strike the United States since 1950. And 2 years ago, Michael destroyed Panama City and Tyndall Air Force Base in the panhandle of Florida. So there it is after landfall over the panhandle. This is an infrared satellite picture, but let's take a close-up look at that. You can see the eye there. Here's the state of Florida I'm trying to outline here. So you get an idea of the size of these storms. This is a very classic textbook example of a hurricane. And again, only 3 times have we had a Category 5 a hurricane strike the United States since 1950. Move on to last year. You probably don't remember any of these storms, right? Well, there was one here that was pretty important. It's called Dorian. And Dorian was a major hurricane chugging away right for the state of Florida and made a right turn and exited off the East Coast. Just scraped along the coasts of North Carolina and South Carolina, but it didn't go across the Bahamas. So here's a picture of Hurricane Dorian from last August. And what you see there is the eye of the storm right over the Grand Bahama Islands, and here's the state of Florida. This caused great devastation in the Bahamas, and there you can see a picture of just some of the damage. Trees totally debarked. We have boats and cars scattered across the entire region, and most of the structures were severely damaged or totally destroyed. So far this year has been a very active year. We're only into the end of July, and we've gone through many storms already. You may remember Faye earlier this month came right across the New York City area as a tropical storm. But earlier in the week here, we had Hurricane Hannah make landfall near Corpus Christi, Texas as a Category 1 hurricane. So a very active year so far and expected to continue to be such. So here's a picture of Faye coming up the coast here. And again, it produced some heavy rain and some fairly gusty winds, but really not a major impact to the tri-state region. So this is what's expected to be coming up. This is a potential tropical cyclone. This was as of yesterday. At the end of the presentation here in about 40 minutes, we'll take about a few minutes and look at what's actually happening right now. But this is a potential tropical storm that's going to be impacting Puerto Rico, Dominican Republic, and Haiti, up through the Bahamas, potentially Florida, and perhaps, just perhaps, up into the southeastern and Atlantic coast. So we'll take a look at that here at the end. So let's go back and look at what is a hurricane. We've all talked about hurricanes. We saw a picture of one. We could identify that pretty easily, but it's simply a cyclone or storm that forms over the tropics, over the water. We do not have these storms forming over land. And we refer to these as tropical cyclones as a generic name for these storms. So the background on where hurricane came from is from the culture of the Mayans. Early on, for early explorers, came to work the name hurricane. So that's where we got the name hurricane for in our portion of the world, in North America. In the western portion of the Pacific, these storms are known as typhoons. And over in the Indian Ocean and around Australia, we simply call them cyclones. But they're the same meteorological phenomena. There's really no difference meteorologically between a typhoon and a hurricane. The difference is where it's occurring. So there are no fronts. There's no cold front, warm front. If you remember your 9th grade earth science, you learned about all these different types of fronts that produce weather. With a hurricane, there are no fronts. And there's no jet stream. If you watch the weather on TV or on the Weather Channel, they often talk about the jet stream and how that produces these storms. But in terms of a tropical cyclone, a jet stream is detrimental to the storm itself. And if it happens to encounter any of the jet stream, it'll certainly weaken. So hurricanes are not related to having a jet stream associated with them. So again, hurricanes, typhoon, cyclone, we're talking about the same meteorological phenomena, and we refer to those as tropical cyclones. They're simply low pressure areas in a tropical maritime air mass. similar to what's been, we've had maritime tropical air mass across Long Island the past several days, as you know. And the wind speeds, the average wind speeds, the maximum sustained winds, that's the average wind, has to be at least 65 knots or 74 miles per hour. So here's two hurricanes. You can see one that's made landfall near New Orleans, and then one that's well offshore. So you get an idea of the size. They do vary in size, but they certainly are much smaller than our winter storms, than our nor'easters. So take a look at those pictures now, and we'll take a look at this. Looks like a hurricane, right? You can see there's sort of a center of circulation right in here. You say, oh, that must be a hurricane. Well, if you look back here, this is all snow across the ground, across Long Island, across Connecticut, Massachusetts. And this happened about 7 years ago. And you might remember this storm. It's the one where they were picking cars off the LIE with payloaders as we had about 2 feet of snow. So this was February 9th of 2013. And some refer to this storm as Nemo. So it is a extratropical cyclone. Has some looks of a hurricane, but this is a winter storm or a nor'easter that brings us tremendous amounts of snow and is associated with fronts and the jet stream. So different meteorological phenomena. So where do these storms occur? We look here in the North Atlantic. We have storms coming out of the tropics. They tend to move up and out into the North Atlantic. They come towards the Gulf of Mexico. They come off the west coast of Mexico. They're still called hurricanes. And earlier this week, we had a hurricane come off this region, past just to the north of the islands of Hawaii, called Hurricane Douglas. So the storms do track towards our 50th state there in Hawaii. So here in the Western Pacific, we have typhoons. And then we have cyclones here in the Indian Ocean, both north and south, and cyclones around Australia. So many parts of the world are affected by these storms. For us, it's late summer, early fall for our storms. So we're just now getting into the peak of our season. I wanted to take a look back at some of the history. These are some of the storms that have produced devastating results, especially in the Bay of Bengal. I'll point out where the Bay of Bengal is. So it's right here. So this is the country of Bangladesh, and this is the subcontinent of India in southern Asia. So it's this region right here that's been prone for some very devastating storms that have killed literally hundreds of thousands of people. And one storm I wanted to point out is Cyclone Nargis here, which occurred in May of 2008, so just 12 years ago. And that killed an estimated 138,000 people in one day. And that was in the country of Myanmar, which used to be, I guess, Omar. I forget, sorry. But Myanmar is here on the eastern side of the Bay of Bengal. And the US tried to offer assistance to them, but they refused to take it. So it's kind of interesting there. Okay, so moving on. What happened in the United States? Greatest natural disaster in the history of our country occurred in 1900 in the city of Galveston, where 8,000 to perhaps as many as 12,000 people perished. 3 years ago, we had Hurricane Maria that resulted in significant loss of life in Puerto Rico. And the numbers of fatalities range from a few hundred to perhaps as many as 4,000 people that lost their lives directly or indirectly as a result of that. So that could fall in here as well, but pretty significant storms. And if we look a little closer here, we see that as we get closer in time, most of these were long ago, except for Katrina. 2005 Katrina estimated about 1,800 fatalities. So these are very significant, not only in terms of impacts to people, but also to the economy. Here's a graphic showing the areas that are vulnerable in the United States. So you see these red areas. This is Cape Hatteras here in eastern North Carolina, the southern part of Florida, the Gulf Coast. But when we get up to Long Island, we see the average return period is 1 in every 18 years. So that results in a probability of about 6% of a hurricane impacting Suffolk County each year. That doesn't mean that once every 18 years we're going to have a hurricane. It means that we have about a 6 or 7% chance each year of having a hurricane. We could have 2 in 1 year. We could go a period of 50 years without a hurricane, or we may have 3 in a period of 5 years. It's just a probability that any year we are vulnerable to having a hurricane, and the probability is about 6 or 7% of significant impacts of an actual hurricane passing across Suffolk County. So if we look at some of the economic damage that's occurred, we look at this graph and we can see it's obviously increasing with lots of lines up high here. So we look at some of this. This is Hurricane Andrew, which was a Category 5 impacting southern Florida. This peak here is Katrina, and then we get to Hurricane Sandy, which you all remember, I'm sure. And then more recently, we have Hurricane Maria and Irma. So what's changed in the past 100 years? Well, we've moved to the coast, and there's a lot of increase in population along the coast. So these are tropical storms that form over the oceans, and they impact the coastlines. So when I grew up in the 1960s, there weren't a lot of people in Suffolk County, and that's certainly changed. We have a great population right along the coast. In the South Shore, we have the Fire Island region. Things have changed quite a bit. And in Florida, the population has nearly tripled in places like Miami and Fort Lauderdale and along the west coast of Florida. So Tampa, and you may have friends in Fort Myers or that region. There's been a tremendous increase in population and extremely vulnerable to hurricanes. If we go back here, you'll see that this region down here, very vulnerable with a return period of about once every 5 years. So about 20% chance of any particular year of having a hurricane. So how do these storms form? Well, the first ingredient, we look at the parts that are needed, we need to have warm water. So we need temperatures of about 80 degrees Fahrenheit, 27 degrees Celsius or higher. The reason that the warm water is needed is that that provides the release of latent heat or heat energy from the condensation of water, and the release of heat lowers the pressure. So hurricanes are produced by latent heat releasing warm temperatures that lower the pressure that increase the winds. So that's a key ingredient. You need to have warm waters, and our water temperatures are warmest as we get towards the end of August, early September timeframe, which turns out to be the peak of the North Atlantic hurricane season. The other thing is we have to have some Coriolis effect to get the storm spinning. So if you remember to that graphic I showed earlier where these storms occurred, they don't occur at the equator. In fact, if you're looking for a very safe location to be away from hurricanes, the equator is it. You do not have hurricanes or tropical cyclones at the equator. Perhaps you've been to the island of Aruba, and Aruba sort of advertises itself as hurricane safe. It's only about 11 degrees north latitude. So the Coriolis force is relatively small there, and typically hurricanes do not affect the north portion of South America. But here's the key thing for hurricane formation. We have to have little or very weak wind shear. And what that means is that the wind direction and wind speed through the entire portion of what's known as the troposphere, where our weather occurs, has to be the same. And wind shear is either the generator or killer for these storms. we could have water temperatures of 30 or 32 degrees Celsius, but if there's wind shear, these tropical cyclones will very quickly weaken and dissipate. And we have to have a disturbance. We need something to start with. So tonight in the Caribbean, we have a disturbance. We have enough Coriolis effect. We have plenty of warm water, but so far, the wind shear has been enough that this storm has not really developed. So we have a potential for a tropical cyclone to form. Speaking of warm water, this is a satellite picture of the infrared temperature of the ocean collected yesterday, the 28th, early in the morning. I just want to show you how warm the water is south of Long Island. You can see the Gulf Stream here coming off the Carolina coast with temperatures running at about 30 degrees Celsius. That would be about 86 degrees Fahrenheit. But south of Long Island, temperatures are still in the 26 degree range. So upper 70 degree water out here south of Long Island. There is a little bit of upwelling taking place off the South Shore. So right near the coast, temperature is a little bit cooler, but still very warm water right along the coast here. And even the coast of Jersey is a little bit cooler with some upwelling where the water is being pushed offshore and the cooler water comes up from below. But still, for this time of year, the water temperatures are very warm. And another thing that's been in the news is the warm waters that have been all the way up to the coast of Maine. You can see the water temperatures in coastal Maine are well into the 70s there with 23 degrees Celsius water. So very warm water here in the Northeast for this time of year. So the life cycle of a tropical cyclone begins as what's known as a tropical depression. We have about 16 each year in the North Atlantic. And to form a tropical depression, we need a disturbance, warm water, a lack of wind shear, and a drop in pressure so that we can have a circulation form. And again, the release of the latent heat of condensation allows that pressure to drop from thunderstorms. So a cyclonic circulation, which will be counterclockwise in the Northern Hemisphere. And wind speeds have to be below 39 miles per hour and is classified as a tropical depression. Once the wind speeds increase above 39 miles per hour, it's classified as a tropical storm. So of those 16, on average, tropical depressions, 12 of them become tropical storms in the North Atlantic. The pressure lowers, the wind speeds increase, and it gets a name. So we don't name our storms until they become tropical storms. So sort of quickly here, talking about the names. The names are set up by the World Meteorological Organization on the United Nations in New York City. We have a 6-year cycle and big storms get retired. So here's the list of names. Well, let me go on to the hurricane first and then I'll show you the list of names. So we have a tropical storm, it gets a name. If the wind speeds increase above 74 miles per hour, it becomes a hurricane. So once the pressure in the center lowers, it becomes a hurricane. About 6 or 7 of those 12 tropical storms become hurricanes. So far this year, we've had several tropical storms, but only one has become a hurricane. So we've only had hurricane that occurred earlier this week going into Texas. So once it becomes a hurricane, it goes on to this category scale, which you've certainly heard of, the Safra Simpson intensity scale. And just to show you that, this is based on wind speed. So the stronger the wind speed, the higher the category, the more intense the damage, similar to what we have for tornadoes. So here are the tropical names. So we went from Arthur, Bertha, Cristobal, Dolly, Edouard, Faye, which came across New York City and Long Island, Gonzalo, which wasn't expected to become a hurricane, but dissipated before reaching the Windward Islands, and just this past weekend, Hannah. So here are the rest of the names for this year. So these are the names for 2020. There's a 6-year list here. And every 6 years, or actually 5 list, and then they'll repeat. So in 2025, we'll go back to Arthur, Bertha, Cristobal, Dolly, Edward, Faye, and this will repeat itself in 2025. If there's a big storm like Sandy, the name gets retired and replaced. So in 2012, we had Sandy. This is the same list from 2012, and Sandy is now Sarah. So we don't want to use the same name twice of major storms. So where is all this information coming from? It's coming from your government. The U.S. Department of Commerce runs NOAA, the National Oceanic and Atmospheric Administration, and that runs the National Weather Service. So the information is coming from federal employees, scientists that work for our government. And the National Hurricane Center, which is part of the National Weather Service, is located in Miami, Florida. It is under NOAA. You see that this is the building itself, which is built to withstand in excess of 150-mile-per-hour winds. This is part of the National Weather Service. So it's a federal organization that provides this information to our media, to our Weather Channel, to anybody who would like to have it. And then locally at Brookhaven National Laboratory is the Tri-State Area's National Weather Service, where I'd worked for 25 years, and that provides local tailored information using the information from the Hurricane Center and tailoring it for what's going to happen in Suffolk County all the way out into Orange County, New York, across southern Connecticut and the northeastern portion of New Jersey. There's about 20 million people living in that region, and the National Weather Service employs about 25 total scientists and staff. So here's an important thing to think about as we go into the end of summer. The likelihood of hurricane activity increases. So right now we're coming up towards the end of July, and you'll see that typically we don't have a lot of storms. These are the total number of storms, but as we get towards beginning of September, there's certainly a very high likelihood that there will be a hurricane somewhere in the North Atlantic. So this is the peak of our hurricane season here coming up about September 10th. And what's also interesting is Sandy occurred down here as we are really weak ending our hurricane season. If you had asked me in 2011, what's the chances, Jeff, of having a hurricane impact Long Island at the end of October? And I would say, well, that's probably unlikely. I would certainly bet against it. So a lot of strange things have happened that we never expected. So it was pretty amazing to have that storm the October 29th. And of course, a week later, it snowed. So weather is always amazing, and sometimes really does surprise even scientists who've done this their entire lives. Here's a interesting web link. I'm gonna try to see if I can get this to work, maybe. And I'm gonna have to change what I show, but it's coast.noaa.gov/hurricane. So let's see, I gotta do that. And then I have to share the right screen. New share. And let's try this. It didn't work. Hopefully you're seeing my browser.
We see it.
Okay, good. Okay, here we go. So coast.noaa.gov/hurricanes.
I will also be putting it in the chat box too, so that they have it.
Okay. And you can put in any location you'd like, as long as the browser cooperates. Reach New York. There we are. So what we can do here is we can drop down this distance. Whoa. And we'll find storms that have passed within, say, 75 miles of center reach. 75, not 755. Sorry. There we go. Sorry about this. Those are the 755 mile ones. We want to get to 75 miles. Getting closer. I think that picked it up. And if I could zoom out. There we go. So these are all the storms that have impacted central Long Island within 75 miles, going back, I believe this goes back into the 1800s. It's by year. There are 58 matching storms here within 75 miles. But what's missing? Sandy. We'll take a look at Sandy here in a minute, but it's not on this list because the center of the storm didn't pass within 75 miles of central Long Island. So we could go back to Irene. This was Hannah 2008. At the time, it was a tropical storm, but we can go back to one of our more famous storms here, if I can get to it. 1985. And Gloria as a Category 1 hurricane passing directly across central Suffolk County. So if you know anybody who was on the island, or if you were on Long Island in 1985, you certainly remember this storm at the end of September. So this was very devastating to Long Island as a Category 1 hurricane. Okay, let's see if I can get back to the PowerPoint here. There we go. So what do these storms do in terms of fatalities and serious problems in terms of human life? Most people that experience the storm, the most deadly portion is the storm surge. So this is right along the coast. This is where people die in places where the salt water rises up due to the winds pushing the ocean or other body of water up onto the land surface. So along our South Shore, this is a problem for them. Along the North Shore, because of the high terrain there, it's only the immediate areas right along the water line. So if you went down to the Port Jeff Village, some of those areas did flood during Sandy, but for the most part, there was not a lot of problems with storm surge along the North Shore. The second other problem here is rain-induced flooding. So this is fresh water flooding. This is just rainfall and flooding that occurs, so that's a problem. For us on Long Island, our sandy soil helps us quite a bit there, but our real problem is this little wedge down here in central Suffolk. It's the wind, and we'll talk about that here in a few slides. So here's Sandy, and you can see the storm here on the right side. This is October 29th of 8 years ago. And on the right side is an infrared satellite. The eye of the storm is just discernible here off the Virginia coast. And it's a large circulation, had a large cloud field, actually produced snow out here in West Virginia. But the storm tracked inland and made landfall around Atlantic City that evening, more than 75 miles away from center reach. So that's why it didn't appear on that track map. These are some of the winds that occurred with the storm. And some of the strongest winds that were reliable was 78 knots or 90-mile-per-hour wind gust at Islip MacArthur Airport. This 83 that's up here was at Eaton's Neck on an elevated, on top of the lighthouse. So that was not quite representative. But you'll notice that the higher wind speeds are all occurring here on the right side of the storm. So this is the most dangerous and windiest side of the storm, not directly along the track, but off to the right side. The Safra-Simpson wind scale, what you see here is it's truly just a wind scale. It doesn't have anything to do with storm surge. We can have a Category 2 storm produce catastrophic storm surge. Sandy, which was Category 1, produced extensive storm surge that was deadly. So the intensity really does not equate well in terms of the storm surge. So we've tried to refer to the Safra-Simpson wind scale. Just some of the storm surge damages. This is Rockaway Beach before and after. You can see the damage there, and I'm sure everyone has been along Ocean Parkway and seen the damage there. That's been repaired now, but part of the parkway was washed away from Sandy. Over time, the forecast accuracy has improved significantly due to increases in our observational tools. The satellites that NOAA operates that are in orbit produce tremendous ability to observe the storms. In addition, we have high-speed computers that are used to make predictions about the storms, and we'll take a look at one of those coming up here towards the end. One place that hasn't made a lot of improvement is the intensity. So the intensity forecast still is very problematic in terms of hurricane forecasting. There's been some improvement, but you can see this is more of a pretty scattered looking diagram. And from year to year, we may look like we're making improvement, and then we have a large increase in errors. So though there's been improvements made in forecasting location, the intensity still remains a very difficult problem for meteorologists. So locally, our impacts are storm surge, heavy rain, and wind. And again, one thing that I hope you'll take away from this presentation is that no two storms are going to be alike. We shouldn't be comparing future storms to what happened with Sandy, because they'll be very different based on the time, the track of the storm, and the distinct characteristics that each storm brings. So no two storms are ever going to be alike in terms of what they do to Long Island. So this was a track of Sandy. And the mayor of New York at the time, seeing this graphic, said, well, okay, we can send some people down to Jersey because it looks like they're going to get the storm. Of course, Mayor Bloomberg didn't understand that the top line up here talks about how this cone of uncertainty is only for the track of the center of the storm, not the impacts that can happen well outside the storm, as they did during Sandy. So Sandy produced storm surge similar to a Category 1 wind gusts. Most of the wind speeds were actually more of tropical storm intensity, but the storm surge did reach in parts of New York City as high as 12 feet. And if we look at some of that storm surge, this is actually the inundation, how deep the water was over land. And you can look out here towards Fire Island and Long Beach and Jones Beach, that there were reports of 4 to 6 feet of water above the land. Even on the North Shore, some areas of 3 to 4 feet. But it was around New York City where the subways and the tunnels got flooded with upwards of 8 feet of water above the land surface. So this is called inundation. One of the things that happened on Long Island Sound was, fortunately for the people living along Long Island Sound in Connecticut, the storm surge came in towards low tide. If the storm surge had occurred about 6 hours later, there would have been 6 more feet of inundation. So this is at Kings Point in northern Nassau County. This is what actually occurred. The level was recorded at 14 feet. But if we moved that storm surge just 6 hours later, we'd been close to 20 feet or 6 more feet of storm surge. So some of the more vulnerable places like Bayville and Centerport on the North Shore of Long Island could really have been devastated if this storm had been just 6 hours late. Yep, they bring heavy rain. I think you'll all recognize that. And LIPA at the time of Sandy said that most of its customers, almost 85% of its customers had lost power during Sandy, which surpassed the record from Hurricane Gloria. And again, why did we lose power during Sandy? Trees. Trees are a big concern for those in the center portion of the island, or any portion of the island, because a large tree coming down, if you're underneath it, it's thousands of pounds. So these are some of the problems. Large trees falling on top of cars, on top of people, and you'll see this tree has been uprooted here. There's a sidewalk. There's probably been a cut made here for the road, and the roots grow more parallel to the road, so they become more vulnerable to toppling over. And our oak trees, which are very strong trees, if they come down, they can destroy your house. And if you're outside, you could be killed. This would be the worst case for us on Long Island, to be a storm coming into central Jersey as a category 2 or 3. This would be our worst case scenario, and it's not unrealistic to happen. The storm will be accelerating up to the north and making that bend back to the coast. So this is just not a forecast or something that's actually happened, but this is the worst case scenario that the emergency managers, the county officials, the state officials all train for. So here are their takeaways. We generally have a 5 to 6% chance that a hurricane will affect Long Island. And the reason I use that word affect in there is, remember Sandy, it went into New Jersey. In fact, it went into southern New Jersey. But if you were on Long Island, you certainly remember the effects of that storm. Possibly worse than Sandy will occur during your lifetime. May occur this year, may occur 5 years from now, but you certainly need to be prepared for what it could bring. I was working at the National Weather Service during Sandy. After the second day of going back into work, I didn't understand why all these people were waiting in line for gas. Certainly remember the gas problems. It's like, well, I had plenty of gas. I had a full tank of gas, but I'm like, why are people waiting for gas? I mean, there's power, but of course there was no gas because of the distribution, and many of the gas stations had lost gas. So we hoarded the gas pretty quickly. Problems with distributions, and the same thing that happened with COVID recently, the paper shortages and such. So you need to be prepared and think about what you would need. And I never thought that we'd have a problem distributing gasoline. I certainly had a full tank of gas in my cars, but I thought within a few days we'd have no problems. And of course that continued for at least a week. And then it snowed. Don't focus on the track of the storm or even the cone of uncertainty of the track. You need to look at what the impacts may be on the outside of the storm. So we're trying to communicate that becomes a little more difficult because those graphics appear on every television, and you see that little cone and you quickly decide that, oh, okay, I'm outside the cone, so everything will be fine. And of course, that wasn't the case back in 2012. And again, you have to prepare for the worst and hope for the best. No two storms will ever be alike. So here's a website. This is the local National Weather Service in Brookhaven. So it's simply weather.gov/NYC. They have lots of information there about what you need to do, what you should do, what supplies you should have, things you may not have thought about, but certainly there's a lot of good information, and it's coming from your local government source. So you don't have to be searching around and trying to guess what type of storm that is expected to occur. Many of the people that work at the Weather Service have been meteorologists for 20 to 30 years and have an amazing amount of experience. One thing up here, I put this up from the Red Cross. It talks about hurricane watches and warnings. This is when conditions are expected within 48 hours for a hurricane watch, and a hurricane warning is issued by the National Weather Service 36 hours before the conditions are expected in our region. Those may be the official warnings and watches, but unless you're living in a cave, if there's a tropical system approaching Long Island, you will certainly have heard about it from someone because the media is very adamant about this. So I'm currently down in Florida, and this was the front page of our paper. I'm in North Central Florida right now, and this was the front page of our local paper, and it's about a tropical system that's yet to form, and it says tropical system puts state on alert. I was like, wow, that's pretty amazing. And get your supplies ready. This is something that may affect as a tropical storm into Florida come this weekend. So they led that in the newspaper, and the 6 p.m. news here in Orlando. That was the #1 story about a tropical storm that had yet to form. I thought that was pretty amazing. So here's a couple websites we're just going to take a look at here in closing. One is the National Hurricane Center, which is nhc.noaa.gov. And then we have something called Tropical Tidbits, which is a website that a graduate student and now faculty member, I believe, at Florida State University in Tallahassee put together, which is very popular with meteorologists. So let's see if we can go over to those. And I think I can get there. Share this. And I'll go to the, I think this is the NHC tab. It is not, that's Tropical Tidbits. So I'll just put in NHC. So this is the National Hurricane Center, again, which is part of NOAA and the National Weather Service. And they're issuing advisories on potential tropical cyclone. So this is a storm that potentially will be affecting land within the next 24 hours. And we'll take a look at that, and we'll look at the track of it. Here we go. So you can see the storm here south. This is Puerto Rico. All these little blue shaded areas are where there are tropical storm warnings in effect for. So that's the Dominican Republic and Haiti. So this region is under a tropical storm warning. The southeastern Bahamas, the central Bahamas are under tropical storm watch. And you see the track of the storm, which hasn't formed yet, is across Florida by this weekend. But you'll notice that it's still a tropical storm, fairly weak in terms of its intensity. Other things that you can get, there's lots of text data and there's lots of information available from the National Hurricane Center. There's all types of educational resources, records and facts, anything you would ever want to know about a hurricane is in there. So it's a really nice source of information. Jump over to Tropical Tidbits. And this is the infrared satellite imagery, hopefully, coming up here, taken from the NOAA satellite of what is a very disorganized looking, what we call a tropical wave. It's not even a depression yet, that is moving across the Caribbean. And this is the island of Puerto Rico, and this is the Dominican Republic on the top left here. And as we look at this close up, we can see that there's very little organization taking place. For the past several days, meteorologists had expected this to develop into a tropical storm, and it's yet to do so. So it's continuing to be looked at. This cluster of thunderstorms here is expected to track over Dominican Republic here tonight, tomorrow, and then move up towards the Bahamas. So let's look at some predictions. So here we have potential tropical cyclone number 9. So this is from Tropical Tidbits. Let me show you Tropical Tidbits a little more. Here's the current storm information. There's data from the Air Force reconnaissance that goes inside the storms. There's satellite imagery and there's models. So this is the current storm. But I wanted to show you what these are the spaghetti plots. So these are the tracks that the storm may take, and you can see it goes over this the Dominican Republic, which has some very high mountains to it, that should keep it from intensifying, and then moving towards Florida, or perhaps towards the east coast of Florida, and then up along the east coast of the United States. I thought that's pretty interesting. Here's some more ensembles. You can see the storm kind of moves here towards Florida. This group shows that it's, hey, that's Long Island, isn't it? Yeah. So it sort of tracks off towards the Canadian Maritimes, towards Nova Scotia. It sort of brushes right along the East Coast. So there's some potential here that not only Florida may be affected, but the entire East Coast of the United States. So you may be hearing about this in the coming days. I just wanted to show you one last thing, and then we'll take some, hopefully have some questions. Let's see if I can get to it. Here we go. So this is just one numerical model. This would be valid on Saturday, so it's a forecast of where the storm would be. The black lines here are isobars, or constant pressure lines, so the circulation around the low. Let's see if I can zoom that up. Yeah, I can. So of course, here's Florida, and this is showing that the storm has intensified. The pressure has lowered, and it's probably at that point would be classified as a pretty strong tropical storm in the northern Bahamas. And as it moves forward in time, what you see is that this numerical model intensifies it, becoming a hurricane over the Cape Hatteras, and concerningly close to Long Island. So this is what planners and meteorologists deal with. There's a lot of uncertainty. The storm hasn't even formed yet, but yet there's information available that suggests that somewhere along the United States could be impacted by the storm in the coming days. So I'm not saying to run out and get bread and milk, but you certainly want to be prepared and look at some of these preparedness things that you can take care of now, well before any type of storm. And again, we haven't even begun to reach the peak of the tropical cyclone season in the North Atlantic. So with that, it's just a few minutes before 8 o'clock. I'll end. If we have any questions, I'll try to answer them.
If anybody does have any questions, you just have to put them into the chat because we can't see or hear you. So far, I have not seen any.
Okay. Well, I hope this has been informative. Again, these storms can really be significant impacts, not only to your property, but there are ways to help protect your property, and doing things well before any storm comes, having some supplies, and just a few minor things can make your life a lot more comfortable as these storms do affect the tri-state region and Long Island.
Okay, so if nobody has any questions, I know some people are saying that it's a very informative program that you just had, and they're all thanking you. It was a very job well done. So thank
Great.
you. And thank you
Okay.
to all the participants that are here as well. Is there anything else you would like to say before we close out?
Nope, everyone be safe. It's an interesting year. Things we never expected to happen have happened across the world, and these tropical cyclones will be with us for years and years to come. It's not going to be going away. So spend a few minutes, maybe take a look at the couple of those links, especially weather.gov/NYC, and look at their tropical preparedness. Provide you maybe some tip that's something you didn't think about. You could spend a few minutes now taking care of, and feel a lot safer when these storms do impact us. So thank you for your time, and be safe, everyone.
Thank you.
Good night, everybody.